Iron and sulfur are two elements that occur in high abundance. Iron and sulfur can react to form iron 2 sulfide by the following reaction. In this demonstration, we will look at the difference between pure substances, mixtures, and compounds. Iron is the fourth most abundant element on Earth. This glass tube is filled with iron powder, and I'm holding up a magnet next to it to demonstrate one of its properties. Elemental iron is ferromagnetic and is strongly attracted to magnets, as you can see here. Sulfur is the 16th most abundant element on Earth. In its pure elemental form, it's most commonly found in nature as the allotrope alpha sulfur, which is a ring of 8 sulfur atoms bonded together. Here you can see it as a yellow powder. We observe that it is diamagnetic and does not respond to the magnet at all. What you saw in the previous test tubes were pure elements. Here I've prepared a mixture of the two powders, and I use a blowtorch to initiate a reaction between them to form iron 2 sulfide. After the reaction, I test the product's response to a magnet. We see that it is only weakly attracted to the magnet, telling us that the iron powder has been chemically transformed into a new compound containing both iron and sulfur elements. Comparing the iron sulfide to pure iron, we see just how much weaker the magnetic response has become. To summarize what we've just seen, I've taken two pure elements, combined them to form a mixture, and then they reacted to form a new compound, iron 2 sulfide. Iron 2 sulfide is diamagnetic like sulfur, so you might wonder why it is attracted to the magnet, even if it's only a weak attraction. The answer is that iron 2 sulfide isn't the only product that forms. There is also pyrite and pyrrhotite. Both of these compounds are also diamagnetic, so that means that the magnetism must come from a very small amount of unreacted iron. While we synthesized compounds, the test tube actually contains a mixture of elements and compounds. In addition to magnetism, we can also look at the differences in reactivity between the two pure elements and the compounds they reacted to form. This 6-well plate contains 6 molar hydrochloric acid, and I add each of the 3 materials to test their reactivity. On the left, I've added sulfur, which floats. In the middle, I'm adding iron, which sinks to the bottom. The iron metal reacts very slowly with hydrochloric acid to create small bubbles. The bubbles that form are hydrogen gas. In the well on the right, I add the iron 2 sulfide product. Some of it floats, some of it sinks, but very distinctly you can see large bubbles that form. The bubbles that form from the reaction between hydrochloric acid and iron 2 sulfide are hydrogen sulfide, H2S. Hydrogen sulfide has the smell of rotten eggs and is highly toxic, which is why I'm running this in a fume hood. Speeding this video up a bit, you can see the differences in bubble formation between the iron and iron 2 sulfide. From the top down, you can see the differences in reactivity clearly. Sulfur does not react. Iron starts to dissolve and generates very small bubbles. Iron 2 sulfide generates larger bubbles. The 3 different reactions with hydrochloric acid are summarized here. This difference in reactivity demonstrates the difference between a mixture of 2 pure elements and a compound. The new arrangement of atoms and bonds that occur when a compound is formed lead to new chemical reactivity.